Hi, I'm Harper.
And I'm Nader.
And we're from Brev.dev, and today we're going to fine-tune Mixtral, which is Mistral's Mixture of Experts model.
It's 8 7 billion parameter models. Each one is an expert in something. This is actually architected very similar to GPT-4, which is why we're seeing such great results from it.
Yeah, the way it works is that based on your prompt, it is routed to the most appropriate model. And it outperforms Llama 2 70B on most tested benchmarks. So yeah, let's dive in. We're going to start in the notebook, which I will link. And we don't need an A100 for this. We're going to be using QLoRa, which is quantizing and then using low rank adaptations. And I have an article on how that works, which I will share with you all as well. And I will talk a bit about it as we go through the notebook as we get to each stage of QLoRa. So first we want to instantiate the GPU. And so we can just click this badge right here. And we're going to need a 4x T4. So my other guides, almost all of my other guides, I use QLoRa for fine tuning, and you only need an A10G, which is a smaller, like a 1 A10G machine, which is I think 24 gigabytes of GPU memory. We need a 4x T4. So a T4 is smaller at 16, but we're going to get 4 of them. And so that's about $4 an hour right now. So let's just click deploy. Everything is pre-configured for you. Oh, I have to enter my card. So let me just refresh this because it should have my card info. And it should load everything again. Here we go. Okay. It's deploying. I hope you all have a wonderful holiday season. I think I'll be releasing this as part of the 12 days of Christmas. So I hope you all have a wonderful holiday season. I hope everything is great in your world. Okay, so here we are. We're in the environment UI. And now we're going to click build. And the CUDA version and Python version are already preset for you if you use that link from the guide that I clicked earlier, the deploy now badge link. So let's just let this build. And we're going to wait a few minutes and we'll come back in a little bit. Okay, so we see the instance is building. This is building the verb container, which is kind of like a Docker container. And we're going to wait a few more minutes until it's finished. Okay, cool. So it looks like the machine is done. Okay, cool. So it looks like the machine is ready. Verb is finished, as it says. Your verb container is ready. And unfortunately, the notebook button isn't clickable and it's unhealthy, and it's been a few minutes, so that probably means we're running into the bug that we know about and we're working on fixing it. But the way to get around it is you can read these docs or you can just follow me. And so we're going to say, I'm going to get an iterm. So get a shell and type Brev upgrade. So make sure you have the newest version of the CLI. I do. And then Brev notebook, and then the name of your machine. And then it gives you a link, which we command click to open. And I already have the notebook uploaded, but if you don't have it, just upload it from your machine. So you download it from GitHub. There's a little download button, and then you can just upload it. So we've already gotten the GPU, EV. My dog is very protective of me. We've already gotten the GPU. And so we just want to run this once per machine. So even if you stop the machine and restart it, you only need to run this once. So there you go. We'll give that a minute. And if you see this asterisk, that means it's running. And if it turns into a number, then it has completed. So we'll just wait until this completes. And it's done. Great. Okay, so now we want to set up the accelerator, which should speed up training. And then we also want to set up weights and biases, which is good for tracking training metrics like your eval loss and your training loss. It'll create a graph for you that you can look at. So we're just going to run this, and then it'll prompt me to authorize it. I'm logged in, so I'll just copy this, go back, paste it, and then we're good to go. Now we can move on to loading the dataset. So we want to use the Vigo dataset. It's really great for testing whether fine-tuning works because it teaches the model a unique form of desired output. You'll see when we go through, it's very specific in what it wants, and it's quite unusual. And so the model usually doesn't perform well out of the box on this. And so you can really see that the model has, sorry, I don't know why I'm looking over there. You can really see that the model has done well. So let's load. We want to load the train, eval, and test. We want to print them, just make sure we have it all. This is from Hugging Face. So you can swap this out with your own Hugging Face dataset. Just paste it in here. And so we can see, like, if I go to Hugging Face, Vigo, it should be in datasets. Here we go. Yeah. So if you want a different, this is what I copied here, and then you just paste it back in my, oops, I lost it. It should still be running, so we should be good. Great. Yeah, so we have them all loaded, and then again, yeah, so you would just paste that right in here. Okay, so now we want to load the base model. So again, we want to load Mixtral 8x7b, so the mixture of experts model that apparently does, I think, better than Llama 70b. What did they say? Yeah, outperforms Llama 270b on most tested benchmarks. Pretty cool. I guess it's not that cool because it's 8x7b, which is basically 10x7b, but it's still cool. Okay, this will take a minute to load because it's a pretty big model. Okay, cool. So the model is loaded, and now we can move on to tokenization. So this is a screenshot from the Vigo Hugging Face dataset page, and we can see that we have these length distributions. And so you can use that to get this max length variable, which is what we need. We need to set this max length parameter for the model, which will dictate the length of our dataset matrices. And so we want to get the right length because you don't want to overdo it. You don't want to use extra GPU memory that you don't need if the training examples aren't that long. And you don't want to cut off the training examples and lose the data. So you want to get it just right. And so what we're going to do is we're going to load this tokenizer, and we're going to have this generate tokenized prompt. And so this is describing the Vigo task. So Vigo, the dataset I'm using, has this meaning representation, and it has a target sentence, and then it outputs it into this meaning representation. And so what this does, this is how I'm going to format the data that will go into my model. And what I'm doing is I'm just telling the model, I'm describing the task. So we have, describe the target string, so this thing, in one of these functions, inform, request, give opinion, whatever. The attributes must be one of the following: name, release year, has multiplayer, any of these. And so then we have the target sentence, and then the output, which is what we want the model to learn, is how to output it into this meaning representation. And so for every Vigo training example, which is each of these, 1, 2, 3, it will take the target, it will describe the task, take the target sentence, and then the meaning representation. And then at test time, we will give the model up to the end of this meaning representation and hope that it's able to output the correct meaning representation. And so now we're going to tokenize the data set. And if we decode it, we can see that it looks like how we would expect: the description, the target sentence, and the meaning representation. And now we want to plot the lengths because, again, we want the right length. We don't want to overdo it. We don't want to underdo it. So it's pretty well distributed, and let's just go with 340. I think we can fit it. So see, I said 340. We set a beginning of sentence token and end of sentence token, and then we pad so that all of the training examples are the same length. So we can see that it's padded with 2s. It starts with the beginning of sentence token, which is 1, and ends with the end of sentence token, which is 2. And then if we untokenize, we can see that it looks like how we would expect it to, with the task description, the target sentence, and then the meaning representation. which we wanted to learn. And just another note on this, again, they should all be the same length after we pad it, because we're representing the training data as a matrix for our matrix multiplications. So we need them all to be the same length so that our matrix multiplications work. So first, here we're going to see how the base model does. And again, we chose this data set because it's easy to tell that the model learned. If we were to give it just a basic fact data set, it might be kind of hard to tell that the model is actually learning something when we fine tune it, because it might already have access to those facts, and the base model might perform pretty well on what we're training it on. So this data set is really useful in that it's quite an unusual task, and we can expect that the model may not perform very well on it out of the box. So we'll see how it does. So here we can see the sentence that we're taking, and this is what we want the output to look like. And this is what it actually looks like. So we can see it's missing quite a bit. We've got the target string incorrect. So it said informs the verify attribute. It got the name right, but it got has multiplayer wrong and the rest of these wrong. So now we're going to start on LoRa, and LoRa is low rank adaptations. And so what that is taking the original full-size model and making the layers smaller matrices than they were before. So before, we have this model that has multiple layers, and each of those layers is a matrix. And those values in the matrix are updated as the data is passed through the model and back propagation happens. We have to update all of these parameters, and that is extremely intensive for the model, for the machine. And so you need pretty large machines for a typical full-size fine-tune. And so what LoRa does is it makes an adaptation of those layers, those matrix layers, that is a smaller matrix than what it originally was. And so you're actually only training on a subset of the number of original parameters. I guess not subset, but on a smaller number. And so basically we're using low rank adaptation, which is a type of technique, and SVD, singular value decomposition, is the low rank decomposition form that's used in LoRa. When I was looking at the paper, we're able to, again, make representations of these matrices that have a smaller dimensionality, a smaller rank. And so the rank is kind of analogous to dimensionality. It's not the same, but you can, for the math people out there, for the non-math people out there, you can kind of think of it similarly. So it's representing the matrix, but losing some granularity. So it's a bit lossy, but it should have a pretty decent, it should represent it decently. And that's similar to quantization, which I actually forgot to mention. We're loading the model in 8-bit. So what the model originally is I believe 32-bit. It might be 16. And when we load the model, we load it in 8-bit. See here. Oh, 4-bit, excuse me. A different guide that I do is 8-bit. I have so many guides these days. So we load it in 4-bit here. And so the model is either 32 or 16 originally, and what loading it in 4-bit does and what quantization does is it maps those 32-bit floating points to 4-bit fixed representations of those floating points. So it basically shrinks it by a quarter to an eighth, and so you can fit this large model on a smaller amount of memory, of GPU memory. So quantization and LoRa are kind of similar in that way. And so QLoRa is paired. You load the model and you quantize the model, load it in fewer bits. And then you also apply these LoRa adapters, which is low rank adapters, onto the layers of the model. And here we do it on the linear layers to reduce the trainable parameters. And so we're basically representing this model. We're making it smaller, but and we're losing, it's lossy, so we're losing some of that data that it has, but it is smaller and able to fit on a GPU. And in some cases actually might provide some more normalization. So if the model is overfitting because it has all these parameters, in some cases, quantization and providing LoRa adapters actually might help with generalization. So, okay, long-winded explanation of what is going on here. But yeah, let's load the model. And so we have these linear layers, which we're going to apply LoRa to. So we've got QProj, KProj, VProj, OProj, and then these three. And so I list them here and LM head at the bottom here. And I'm going to choose a rank of 8. So rank is the rank of the low rank matrix using the adapters. And so it controls the number of parameters trained. And so we just talked about this. And so a higher rank will allow for more expressivity, but there's a compute trade-off. And alpha is the scaling factor for the learned weights. So the weight matrix is scaled by alpha over R. And so a higher value of alpha assigns more weight to the LoRa activations. So we're going to have the activations have about 2 times the rank, which is pretty common for LoRa that I've seen. And then dropout is usually 0.05. That helps with regularization. Randomly just drop out values. Cool. And so now we can print it and we can see that these linear layers that we saw before have all of these LoRa adapters on them. So yay, okay, cool. And so now we've gotten to the moment of truth, training. So we can run this. We have 4 devices, so you should have 4 if you're using the Brev link. And project is the Vigo fine-tune. You can rename this. This is for weights and biases. And you can comment that out if you don't want to report it to weights and biases. And yeah, I'm just going to run this. So I'm going to run it for 500 steps. I'm setting the learning rate to 2.5 over 10 to the 5th because that worked well in the Mistral run that I did before. And I think it's about 10 times the Mistral learning rate. Not Mistral, but I'm assuming maybe they're similar. But you can tweak that. You can do a hyperparameter sweep if you would like to make your model really good and tweak things like the learning rate. And I'm saving every 50 steps and I'm evaluating every 50 steps. So every 50 steps, I am saving a checkpoint. And so I might see that an earlier model, so say checkpoint 300 at training step 300, it'll have a training loss and an eval loss. And I might find that that model performs better, so it has a lower loss and a lower training, lower eval, than a model later on. So perhaps a model starts to overfit where the eval loss is higher, so it starts to go up, but the training loss goes down, but the eval loss goes higher. And so what that means, this is overfitting, and what that means is that the model is learning its training data really well, but too well. It's not generalizing. It's making this elaborate curve around the data set, but that curve is actually doesn't generalize well to like the rest, to the eval data set. And so we might find that we want to use a model that doesn't overfit. And so we want to save these checkpoints and load an earlier model potentially. So we'll see, and we're going to log every 25 steps. And I'm doing per device train batch size is 1. I know that's small, but it works with my GPU size. You could actually probably tweak this, play with it, and see if it doesn't crash on you. And if it does, it's no big deal. Just reload the machine or restart your kernel, depending on how bad it is, and run this notebook again. So one thing you'll want to do before you leave your model to train is you'll want to open another shell and run caffeinate, and this will prevent your machine from going to sleep. So turn the brightness down all the way and leave your machine. You don't want it to go to sleep while it's training because you'll lose the training run. Okay, so we have run it for 500 steps. I should have gone for longer actually. So I'm going to update this for you guys to go to 1,000, and you can always stop it early by saying kernel, interrupt kernel, because we can see, and let's go look at the weights and biases graphs just so that we can practice looking at it. So see, the eval loss is going down, and I don't know why it only has 1 point here. Something messed up with the graph. That's a bummer, but we can see the eval loss is going down, and once it starts to climb again, that's when it's overfitting, and it's not terribly overfitting, but we can see it's maybe perhaps starting to overfit. But I don't know if there's really enough data points to see. I would probably, if I did it again, I would probably train for 1,000 steps or even longer. You can always cancel it early. Let's see how the model does. We saw it didn't overfit and it continued. We don't have the training loss graph for some reason chart, but we can see that it continues to go down. So it doesn't seem to have converged yet. So I would train for longer. Okay, so let's restart the kernel. And then we're gonna load the Mistral 8x7b base model, and then we're gonna load the LoRa adapters on top of it. And I have checkpoint 500, and let's load both. And I'll be back in a minute to run the same test prompt that we ran before, and hopefully it does better after training for about 500 steps. Okay, so compared to how it did before, we can see this was how we want it to do. And before, again, it got inform, so it got this wrong, and it said has multiplayer Little Big Adventure. So it didn't do very well at all. And this is the gold label, and ours also went over, but it says verify attribute, great, got that right, got the first part right, got the rating close, has multiplayer, got right, platforms, PlayStation. It seems like, oh no, it didn't get PlayStation, that's the gold. But anyway, it did okay, and it did better. And again, it didn't converge, so I would train it for longer. I would train at 1,000 or even longer, and you can always stop it as soon as you see that the training loss doesn't continue to go down and the eval loss starts to go up. I also want to shout out today, we got 1,000 followers on YouTube and 20,000 views on the original Mistral video. I'm so glad that this has been helpful, and I love connecting with you. I really appreciate your support. This is so fun. So please do let me know if you have any other guides that you want to suggest, or recommendations or questions. I love connecting with you. So yeah, let's connect. I'm on X, I'm on the Brev Discord, and here on YouTube. So, or X, this actually is also going to be posted on X. But anyway, thanks a lot, guys. Happy holidays. And I am excited to see you next time and connect with you soon. Take care.